Yeah, thank you. Thanks for this nice introduction. I want to start with a picture one more time. Do you remember this machine? Yeah, some of you? Nice, nice. It's the hero of my childhood, a good old C64, a Commodore 64. It was released in 1982, and it really shows that I'm growing old nowadays. Anyway, it had 1 megahertz, which is nothing compared to nowadays capacities. It had 64 kilobytes of main memory, 64 kilobytes, and the floppy disks could store 170 kilobytes, which is nothing, really nothing. What no one knows is that there has been a dual-core version, a version with 2 CPU cores. It looked like this. And of course, the biggest challenge back then was about resources. You thought twice before you used an integer. Perhaps a tiny integer was big enough. Perhaps the left part or the right part of the tiny integer was enough. So you really took care about resources. Nowadays, resources are not a big challenge anymore. Nowadays, we have other challenges. One challenge nowadays is that we have to make sure that our software is maintainable in long time. We write business applications or other applications, and we have to maintain them for 10 or 20 years. And this is on the one side. On the other side, we have this issue with milk products. Perhaps you have heard about it. There are milk products out there lasting longer than some JavaScript framework. Did you experience that? So this is somehow a trade-off, and web components can be a remedy for this. And this whole workshop is exactly about this topic. This whole workshop is about web components. We will learn how web components can be created with Angular elements. We will talk about polyfills so that our web components work everywhere. We will talk about dynamically adding web components to our pages. And we will talk about loading external web components with your framework, web components with your class libraries. Then we will go on, we will talk about zoneless change detection, which is especially important when it comes to web components. No one wants to load zone.js alongside a tiny widget packaged up as a web component. And we will also talk about content projection and the slot API. In addition to that, I have prepared a bonus. If time permits, we will look into this. This bonus is about using existing web components that have been created perhaps with other frameworks together with Angular. Regarding the didactics of this workshop contains of several tiny presentations. And then there is some live coding. When it comes to live coding, I need your help because, you know, the human brain is a wonderful thing until you start to implement things in front of an audience. Then the brain stops working. So I'm just using the fact that I have several hundred quality managers sitting in front of me. Normally it is exactly the other way around. And then I have prepared some labs, so you can try everything out here. Regarding the labs, there are regular labs, and for those labs you just need a browser. Those labs run within Stackblitz, and so you don't need to install anything. And then there are some bonus labs. I'm calling this the director's cut of my labs, and those labs are for later. If you want to know more about Angular elements, you can do those labs later. You need a full setup for them. Let me also introduce myself. As mentioned, I am Manfred. I'm a trainer and consultant, and I'm focusing on helping companies with Angular. For this, I'm doing a lot of in-house trainings as well as consultancy. I'm part of the Google Developer Expert team, and I'm also a collaborator for Angular. My current product is a workshop about Angular. It's called Angular Architectures for Enterprise Applications, and it contains a lot of advanced stuff you need for enterprise scaling applications. Okay, let's get started with the first chapter here. Let's get started with web components and Angular elements. As you might know, a web component is a framework-independent component, a component that can be written with one framework or with vanilla.js, and it can be reused with other frameworks or even with vanilla.js. And so it helps when we try to establish something for the long term. To be honest, there is not such a thing as a web component, at least in terms of standards, because web components is an umbrella term. Web components is just an umbrella term for a bunch of standards. One standard behind web component is called templates. I think I don't need to talk much about templates. I mean, Angular is full of HTML templates. Each and every component has a template of its own, but also each structural directive like ng-for, ng-if has templates. So I think this is quite a usual thing for us. Another standard is called Shadow DOM, or as we say in German, Schattendom. So please try to say it in German. It sounds more mighty in German. Schattendom. Try it in the break. And this Shadow DOM is a really nice thing because it solves a big issue. Shadow DOM solves the issue that the CSS file of one component interferes with the layout of the other component. Shadow DOM isolates the style of one component to this very component. And this is quite in handy. I think we all know these situations where we have two CSS files, two style files, and where we try to load both of them into our application. While they work separately perfectly, as soon as we load them into our application, all hell breaks loose. The good message here is that Shadow DOM is baked into Angular. Every one of us is normally using Shadow DOM all the time. We are going with Angular. The default strategy is an Shadow DOM emulation. That means that Angular tries to emulate, to simulate this Shadow DOM strategy. We will talk about this a bit more in detail later. Yeah, and the last standard behind web components is called custom elements. If you ask me, this is the most important standard here, because custom elements allow you to create own HTML elements. Own HTML elements that exactly behave like the existing one, like an ordinary table, like an ordinary image, like an ordinary input. And for custom elements, we have Angular Elements since about a year, which is a library that takes an Angular component and exposes such a custom element for it, a custom element that can be reused with each and every other framework. To use Angular Elements, you just need, as mentioned, an ordinary component, an ordinary Angular component. Of course, you have to declare it, and it goes into the entry components of your module. You need this as part of the entry components, as this Angular element is dynamically created. When the browser detects it, the browser is requesting its rendering, and then Angular has to spin off this component. So it is more or less a dynamic component, hence it goes there. In addition to that, you need some wrapping code. And this wrapping code can be placed everywhere. You can place it in the startup file of your application, in the main.ts, for instance. You can place it within a component. You can place it within a service. Here I'm just placing it within my module. For this, my module gets a constructor, and within the constructor I'm calling those two lines of code. The first line of code is pointing to the function createCustomElement. CreateCustomElement is normally the only function you need out of Angular elements. As you see here, it takes your Angular component and it exposes a custom element to the left. You also need to pass your injector in order to install the dependency injection mechanism in your component. That means that this component, which is exposed as an element, can get use of other services by the means of injection. And then, of course, you have to register everything. For this, I'm going here with custom elements.define, which has nothing to do with Angular. This is already part of the browser API that defines how custom elements work. As you see here, the name of the element goes in and the element itself. And after this, you can use this element as you would use a table, an image, or something like a form. It is really as easy as that. And now I want to show you this live and in color. For this, I'm switching over to a project I have prepared. And this project contains a dashboard tile component. Perhaps you have seen it in the session I did yesterday. Today we will see more details about this. When we look into this dashboard tile component, we see it is just an ordinary Angular component. At least if I duplicate my screen, then we see that it is just an ordinary Angular component. And this Angular component gets three values, A, B, and C, nothing special in here. There is a data object, and ng-conf is just populating this data object with my values A, B, and C. Alongside this, it is defining some names, some levels that will be displayed alongside the values. When we look into the HTML of this, we just see an ordinary template, and this template is calling ng-charts. Here we have a pie chart, and this pie chart gets our data bound. I'm also saying, hey, I want to display some levels. That's all. So it is not a big deal here. But the big deal starts when we try to expose this as an Angular element. For this, I'm switching over to my module. This here is my module where I'm declaring my dashboard tile component. And first of all, I have to put it into my entry components because it is dynamically created by Angular elements. After this, I need the wrapping code. I'm putting it into the constructor of my module. I really like this because so my module is providing both Angular elements on the one side and custom elements, web components on the other side. For this, I'm calling the method createCustomElement. I'm passing in my dashboard tile component. I'm passing in the current injector so that dependency injection works, and I'm getting back the element, the wrapped element. Yeah, and this wrapped element can then be registered with the browser using custom elements.define. I'm passing the name of this, which would be dashboard tile, and I'm passing the element itself. That's all. Now we can use this dashboard tile element. For this, I'm switching over to my home component HTML. And here I'm calling my custom element. I'm passing some parameters like A, like P, like C. And as the squiggles here say, there is something wrong here. But let's directly run into this error. By running into this error, I'm showing you some showstoppers you will probably also run into when you try to get started with this. Okay, let's save everything, save all, and then let's move over to my example. And as you see here, the example is reloaded, but somehow it is stuck, somehow nothing works here. Okay, let's have a look into the console here. Let's have a look at the stack trace. And as the stack trace shows, this component is not known. Angular says, hey, blah, 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 I'm very sorry, but dashboard tile is not a known element. And of course, it is not a known element to the Angular compiler because it is not an Angular component anymore. Now it is a web component, a custom element that is rendered by the browser. So it doesn't wonder that this is not known by the compiler. And here we see the error messages are meanwhile really good in Angular, at least some of them, and this is one of them. The error messages are proposing two solutions to this issue. The first solution is When it is an Angular component, then try to register it with the module. Okay, it is not an Angular component anymore, so let's skip this. The second one does make more sense here. It says if it is a web component, then add the custom element scheme for our compiler. Add this custom element scheme to the module in question. So this scheme here is just easing the compiler. It is just opium for the compiler. Please don't cite me. Opium for the compiler that says to the compiler, hey compiler, you will see some elements you do not know. And please don't freak out if you see those elements. Just ignore them. Trust me, those are web components and the browser will take care of them. Okay, so let's take this opium. Let's go over to my app module and let's put this custom element scheme in here. Okay, now the compiler should be calm. We try to reload everything. The application starts up. I'm going to my home page and check, I'm getting the next slap directly into my face. Nothing works, but I'm getting another stack trace. Yeah. So the way to web components is really difficult, as you see here. And now we get an error message directly from the browser, and this one is not as friendly as the error message before. This one says, hey, I cannot construct HTML element. When I have seen this for the first time, I did not know what to do at all. I wanted to jump out of the window because I was afraid. Meanwhile, I know what's going on here. Meanwhile, I know that this awkward error message tells me that I need a polyfill for web components so that they can run in my browser. And this leads us to the next part of theory, which is about polyfill. We have to go through this theory to get started with web components. First of all, the good message. The good message here is that web components can be down-leveled to everything and they can be polyfilled so that they work with each and every browser. Even with legacy browsers, I'm sure you know which browser I mean. So if we look to the browser support, for instance, using can I use, this page you probably know, then we see it works with each and every modern browser. And when it comes to Microsoft browsers, there is some room for improvement. Of course, Edge will get support for web components because Edge will use Chromium in the future, but for IE we will need a polyfill all the time as long as IE is a thing for you. So let me know who has to support IE. Yeah, a lot of people. And this is really a pity, but I know this issue, especially when you have to do projects for the corporate environment, you have to support IE because of all those corporate policies. And so we need polyfills. And one polyfill here is this one, web components / web components.js. I really like this polyfill because this polyfill enables even IE to run web components. It is a bit heavyweight. It is not the slimmest polyfill, but it works with each and every browser out there. The slimmer one don't work, for instance, with older versions of IE. Something that really breaks my heart, I'm honest with you, something that really breaks my heart is that we don't need one polyfill, we need two polyfills. First of all, we need a polyfill for all the browsers that do not support web components. For this, we can just load the polyfill loader, which is in turn loading all the other polyfills we need. For instance, polyfills for templates, for custom elements, or for the Shadow DOM. All the standards I've told you before. And then, and this is the heartbreaking part of it, we need a polyfill called the ES5 adapter for browsers that do support web components. And I know this is awkward. We have a browser that does support it, and even though it does support it, we need a polyfill. So why is this? Well, the reason is web components have been designed for ECMAScript 2015. And nowadays, most of the time, we down-level to ECMAScript 5 to make it run with those older browsers we've talked about. And when a modern browser sees a web component that is down-level to ECMAScript 5, it says, what's this? I'm not prepared to see something like this. I'm prepared to see modern web components based upon ECMAScript 2015, but not web components based upon ECMAScript 5. And so they stop working. And this is what we have seen before. Chrome just stopped working because Chrome was not prepared for seeing a web component that bases upon ECMAScript 5. And so this adapter solves this. A bit later, I have another solution for this issue, another solution that deals with differential loading. But first of all, let's go with this polyfill. Okay, now I can finish my demonstration. Now I can go to my polyfills page, and here I have prepared one polyfill. This is the adapter, polyfill. One polyfill, this is the adapter. And here I have prepared another polyfill which loads just on demand the web components loader, which is loading all the other polyfills for the lacking standards. And now, if we are lucky, everything should work. Let's load this. Let's go to this main page and hey, it works. Here is my diagram, my interactive diagram powered by ng-charts. And this is awesome, or perhaps this is not awesome at all, because perhaps you are saying now, hey Manfred, you don't need Angular elements for this. Everything you need for this is just an ordinary Angular component. And yeah, you are right. For this very use case, an ordinary Angular component is enough. But just think about using this component with other frameworks, or just think about lazy loading this component. In those cases, elements, web components are really in handy. Okay, so much for this first demonstration. I want to ask you to start with the first lab. You can find the description of the first lab under this link here. And I want to ask you to just work on these 2 chapters of the lab description. If you need something, just call out for me. I am happy to help. Great. So I think that really worked well. I've seen a lot of working examples, a lot of pie charts, so congrats on this. I want to show you a tiny hint, something that can help in your real-world projects. Namely, I've written a class library that is called ng-x+. Let me shorten this. ng-x+ can just ng-add to your web page. ng-add, ng-x+, build plus, and then it gets downloaded as well as installed within your project. And as you see here, it is updating the Angular JSON so that the Angular CLI knows to use this extension. And this ng-x+ can do a lot of things. Most of them are helpful with web components, with Angular elements. One thing it can do, and this is important now, it can generate the web component polyfill support. Just type in ng-generate ng-x-build plus : web component polyfill, and then it will do everything for you. It will, let's do it with -force. It will download the web components, and it will update, as you see here, your files, for instance, the index.html file, or if it was not already installed, it would also update your polyfill file. And when this is ready here, then you get the lines of code you have already in your project, the lines of code that have been commented out before. Yay. So at the end of the day, you can automate this. This is just a tiny thing ng-x-build plus can do. It can do also other things. We will look a bit into it later, things that are really necessary nowadays to make use of Angular elements. Okay, so let's go on with this workshop. Let's talk about an alternative to the heartbreaking ES5 adapter. As mentioned before, we need this adapter because the new browsers suppose that web components are based upon ECMAScript 2015. And the solution here I'm presenting is called differential loading, and it prevents that a modern browser sees something like ECMAScript 5. It prevents it by producing two sets of bundles. It produces one set of bundles using ECMAScript 2015 and above, and it produces another set of bundles using good old ECMAScript 5 for legacy browsers. And to make use of this, you just need 3 steps. It is really quite easy. Perhaps you have seen this in another session. It's one of the hot new features of the Angular CLI 8. First of all, you need to adjust the browser list file. The browser list file is nowadays part of each and every Angular CLI project. The browser list file points to all the browsers you want to support. And there, for instance, you could place the string IE9 to 11, so the Angular CLI knows you have to support those browsers and that you have to support ES5. The second thing is that you have to put the target in your ts-config JSON to ES 2015. And so you have both the upper bound and the lower bound. The lower bound says IE, which means ES5. The upper bound says ES 2015. And this is enough for the CLI 8 to produce 2 sets of bundles. Everything you need to do in advance is to create a production build, ng-build --prod, and you will get your bundle sets. Of course, now you are wondering how this looks like, and this is what it will look like. You will get 2 compilations. You will get Webpack both, once for ES5 and once for ES 2015. Let's scroll into this, and when you look at the file names, first of all, go away. First of all, you see, no, that's not the right one. Let's try it one more time. Yeah, this is better. First of all, you see there is a file called ES5. It is the runtime ES5. There is a main ES5, and the same thing is created for ES 2015. Yeah, and this has a lot of advantages. One advantage here is that newer browsers will not see ECMAScript 5. And another advantage is that the ECMAScript 2015 bundles are much smaller, so you can save a lot of bandwidth here. Saying this is only possible with ng-build. This is not possible with ng-serve because that would be too costly for ng-serve. ng-serve has to be fast because we want to get a fast response when we are changing something during the development. Perhaps you are wondering how the browser can decide upon whether to go with the old bundles or with the new bundles, and the answer is this here. The old bundles get the flag no module, and this flag tells the newer browsers to ignore this line of code. And the new bundles get type module, which is ignored by the older browsers. This is the key to differential loading, and so you don't need this polyfill for newer browsers anymore. They will just see ECMAScript 2015. Okay, cool. Let's talk about another topic. Let's talk about Shadow DOM, or the Schattendom, as it is called in German. As mentioned before, Shadow DOM is baked into Angular. It is there since Angular 2, since the first bits of Angular are out there, and by default, Angular is emulating Shadow DOM. You can also do this explicitly by setting this encapsulation property to emulate it. You don't need to do it because it's the default value. When you want to have the real Shadow DOM, the browser-based Shadow DOM, you can set this property to native. Of course, this demands to use just a proper browser, not IE, because IE is not supporting it. This native property is activating Shadow DOM version 0. And as you might think version 0 is nothing that's really trustworthy, isn't it? So the good message here is version 1 is out since some time, and if we want to go with version 1, we can set encapsulation to Shadow DOM. And perhaps you want to turn it off because you're saying, hey, I don't need this, I know what I'm doing, I didn't need it 20 years ago and I don't need it now, then just set it to none. This is for the brave ones. Okay, let me show you a simple demonstration for this. For this, I'm switching over to my dashboard component, dashboard tile component, and here I'm adding some styles. I'm saying, hey, there is a style for card title, and this style comes with the color green. And when the page gets reloaded, then we see we have a green title. But we see something else. We also see that this style does not affect the parent of this component because the styles are isolated now. So just to discover this a bit more, let's turn off Shadow DOM. For this, I'm taking this view encapsulation property. Encapsulation is set to view encapsulation.none. And now when everything reloads, you see now the style leaks through our web component. Now the style also affects the parent, which is normally something you want to avoid. But some people are saying now, hey, I want to style my components. I want to apply different themes. And if you want to do this, using CSS variables are the best way to do. For this, I would say, hey, let's use a variable in here, which is called myColor. And for the older browsers that do not support these variables, let's go with a default fallback. I'm removing view encapsulation none. I want to have Shadow DOM. And all I need to do now is to define this myColor variable. And for this, I'm switching to my styles file. And here I'm saying, hey, I want to add a global theming. And this global theming is defining my color, which is green. And when we reload it, we see that nothing works. Perhaps this is not called global. I'm not completely sure. Is it called root? Yeah, it's called root. I'm also root sometimes. Okay, so you see, yeah, color green. Very nice. So our color is going through this variable into our components. Now let's change the color to something like light steel blue. This is why I love CSS. Every time I'm working with CSS, I'm learning new colors. I did not know that there is something like light steel blue. Okay, so let's try it. Hey, it works. It is light steel blue. And when I'm going with IE, then IE will at least fall back to the default color, which is green. Let's cross fingers. Yeah, the default color, better than nothing, isn't it? Meanwhile, there are also polyfills out there, polyfills for emulating those CSS variables in IE, so you should be on the safe side with this. Okay, so much for this chunk of theory. Let's do a little lab for this. Let's go back to our lab description and please work on the Shadow DOM exercise. It's a really tiny exercise. If you have any question, feel free to reach out. Perhaps a tiny hint. Sometimes clicking here on Stackblitz, clicking, okay, the pointer does not work. Sometimes clicking here on Stackblitz does really do wonders. So if you get an awkward error, just try to reload it with this very button. Not the other one, this button within Stackblitz. Okay, I see a lot of light steel blue titles, which is nice, which shows that you did the example. Congrats on this. And I would say let's go on with the next chapter. We've done this, we've done that. Let's go on with dynamically adding custom elements. This is the first thing that would be far more difficult with traditional Angular components. So the point here is that adding a component in a dynamic way is very easy with web components. You just need this 20 years old code. You just need something like document create elements to create your own web component. And I really like this example because it shows that the browser does not differentiate between the ordinary Angular elements or the ordinary browser-based elements and your Angular elements. It reads your Angular elements the same way as it reads an image, a table, or a div. You can, as you see here, define attributes, you can design properties, you can even hook up event listeners, and then you can add everything to another element so that it gets displayed. Let's do this. So let's switch over to my dashboard tile page. Dashboard, it's called dashboard page. And this dashboard page has a function called add tile. This function shall dynamically add a dashboard tile. And for this, it is delegating to _add, which just gets the name of the element, dashboard tile or table or image or something else. And then within add, I'm doing the magic. Here I'm defining 3 random values because I need 3 values for my dashboard tile, A, B, C. You remember it. And here I can say, hey, please create my tile, document, create element, dashboard tile. And then we can say, hey, I'm assigning a property A, which is data on position 0, property B, data on position 1, and property C, data on position 2. Yeah, and then I'm also defining an attribute. For instance, I'm saying, hey, I have a class, and I want it to be column medium or column large 4. I'm using Bootstrap, as you can imagine here. Then I'm using the document object one more time. I'm grabbing a content element from my page, which is just a placeholder that will get all the elements, all the dashboard tiles. Content equals document get element by ID. And here I'm appending a child, namely the tile. And that should be everything. So let's try it out. Let's go into my page. Let's close Stackblitz. Let's go into my application. Let's go to dashboard. Let's click add default and hey, it works. It is dynamically adding elements to my page. Perhaps you have tried this with ordinary Angular components. It also works with ordinary Angular components, but in this case you had to use a lot of low-level code. Here, as you see, it is really straightforward. Perhaps you are saying, hey, using the document object is not nice at all because of server-side rendering, but the point here is Angular is meanwhile simulating the document object for server-side rendering. You can get hold of it by dependency injection, and then it also works on the server side. This does not mean that you should use this all the time, but when it comes to highly dynamic scenarios, this comes really in handy. Okay, I would say let's go back to the labs description and let's try this out. For this, just work on this exercise here. Okay, I see a lot of working examples. I want to show you something in addition to this, something that only works when you have downloaded everything. That's why it's part of the director's cut of this labs description, namely lazy loading. It is quite easy to lazily load custom elements. For this, you need to register the module in question in your Angular JSON. So the CLI knows that your module alongside all its components shall be lazy loaded. And then you can lazy load everything with the ng-module factory loader on demand. So when you need it, just spin up this loader and use its load methods to get everything into the main memory. Let me show this you in action. It can come in handy sometimes. For this, I'm switching over to my Angular JSON. And here you see this lazy modules property. And this is where the name of my module goes. Here I'm having a lazy dashboard tile module, another module that contains such a web component. When you have done this and when you have reloaded the CLI, you should see something like this here. You should see that the CLI is creating an own bundle for your module. It gets a very long name just in debug mode. In production mode, it is just a number, 0.js or 1.js or something like this. Yeah, and then you can use your ng-module factory loader to load this module on demand. And for this, I'm switching here over to my lazy dashboard tile service. And this lazy dashboard tile service gets the factory loader by means of dependency injection, as you see here. This service has a load method. It has a constant path that points to our module, the module we want to lazy load, and then it is calling loader load. It is passing the path. I'm getting back a module factory, and then I can use the create method to instantiate this module. And as this module is defining web components within its constructor, we can now use those web components immediately after these methods run. It is really as simple as that. Without web components, we needed a lot of low-level APIs of Angular. Now we can just document create element it and document append child it to our page. So let's do this. For this, I'm switching to my dashboard page component. There is a method called addLazy. And this addLazy method tells us that it does not work in Stackblitz because of limitations in Stackblitz. So you have to trust me that it runs in real world. And here you see I'm calling the load function we have seen before. And after this, I'm adding the lazy dashboard tile to my page. Okay, when we look into the template of the dashboard page component, we see that the button for this one is commanded out because, as mentioned, it does not work with Stackblitz. But now I'm commanding it in, I'm calling addLazy, and if we are on the safe side, it works. Yeah, it works more or less. It is loading the old dashboard tile. Let's go back to the dashboard page component. Dashboard page component. It should load the lazy dashboard tile. Oh yeah, here I have dashboard tile hard-coded. This function should take the parameter and create what the parameter says, which is once the ordinary dashboard tile and once the lazy one. And now, hey, lazy loading works. I'm really happy. We see it's another kind of diagram. Nice, I could do this the whole day. Have you seen this animation? I'm really proud of it. And just to prove that lazy loading takes happen here, let me show you the network tab. I'm clicking at lazy, and here it is. So we have implemented a manual lazy loading for just this one component and its module. This can come in handy if you ask me. This is also the base idea of this new Angular project you've heard in the keynote. But now let's go one step further. Let's load an external web component, and this is something that works with Stackblitz. When I speak about external web components, I'm speaking about a project A, which contains a bunch of web components, a bunch of custom elements. This project is compiled into a bundle, and then we can load this bundle into another project. This project B can use each and every framework. It could use Angular, it could use Angular.js, it could use Vanilla.js. Are there other JavaScript frameworks out there? I don't think so. No, I think that's all. So we can reuse it everywhere. And saying this is currently not officially supported because in this case the bundle becomes very big. Even though I show you how to deal with this, and I will show you how you can solve this issue with the big bundle sizes in future. For this we need 3 steps. First of all, we need to create a custom application for the custom elements, and then we need to compile this application to a self-contained bundle, and then we need to load this bundle into our consuming application. I have already prepared an own application for my external dashboard tile. This application is just providing this and only this tile. Let us have a look into the source code of it. To be more precise, let's have a look into its app module. And here you see something that might look quite familiar to you. I'm defining the external dashboard tile component in here, and it also goes, as mentioned before, into the entry component section. This is nothing new. But when you look at this, you will see something that is not quite usual. Have you seen something like this before? Who has seen something like this? We don't have any bootstrap component because we don't want Angular to bootstrap an Angular component when it starts. We just want to have a bunch of custom elements. So this here is empty. But Angular is saying, hey, either I am bootstrapping or you are bootstrapping yourself. That means when I don't have a bootstrap component, I have to provide this ng-bootstrap function, this method here, just to bootstrap something in a manual way. And this is where the magic for creating my Angular component goes in, or to be more precise, for creating my custom element. I'm calling one more time create custom element. I'm passing in my external dashboard tile component. The custom element comes out, and then I'm registering this with the browser. Okay, so when we try to build this using ng-build, we will see that we get a lot of bundles. And we see that using the CLI is sometimes an exercise in patience. Yeah, run forest, run. And the last miles are the hardest ones. Yeah, here we are. We got a lot of bundles. And this is a good thing for an ordinary single page application. This is not a good thing for a dashboard tile for a tiny widget. No one will use this if they have to include all those bundles. And so it is a good thing that my side project, ng-build plus, which I have installed before, has this single bundle flag. And when we are using it, we just get one and only one bundle. So let me run this in the background because we don't have time. And Windows is really good with executing stuff in the background, trust me. Meanwhile, I show you how to load this bundle. For the preparation of this workshop, I have copied this bundle into our assets folder. During the next exercise, you will discover it to be part of the assets folder. Perhaps I'm finding it. Here is the assets folder. And when we scroll down, we have the external dashboard tile bundle. It contains some beautiful lines of ECMAScript 5 code. Isn't it beautiful? Okay, let's go away and let's load this now. For this, I'm switching over to a prepared external dashboard tile service. And here I will implement a simple script loader. First of all, I'm checking whether this bundle has been loaded. If it has already been loaded, I'm doing nothing. I'm really good when it comes to doing nothing. Otherwise, I have to load my script, and for this I'm implementing a simple script loader, the simplest one you can get on this planet. I'm creating a new script element, then I'm assigning to the script element the source, which points to my external dashboard bundle. Just let me copy the relative path. Check. Let me think twice. This is not the right file. Where is my bundle? Here it is. Let me copy the real relative path. This looks better. And now let's change this slash by a forward slash. Let's exchange the backslash with a forward slash. After this, I can add everything to the body of my document, append child, script. This is my simple script loader here. Okay, let's move to my application. And now if everything works, I should get my external dashboard tile. Okay, somehow I've screwed it up. Add external, what's going on here? Let's reload the page. Reboot is good. No, nothing works here. Yeah, here it is. Whew. Yeah. Whew, my nerves, I tell you something. Yeah, so my script loader seems to work and I can add my elements to the page. Nice thing. As mentioned before, this is not officially supported. This is probably what you want to have when you are using elements, because probably you want to load it into another application. It's not supported because of bundle size. I will talk about this after the next exercise. But first of all, let's come to the next exercise, which is about loading an external web component. If you need anything, just reach out to me. I think we have a lot of winners and no losers. Everyone, almost everyone, did this example. Congrats on this once again. And as mentioned before, the biggest drawback of this is the bundle size. When we look at the network tab and when we reload everything, and when I'm clicking at Add External, then look at this, 426 kilobytes. This is not little. This is really not little. So if you get paid by the amounts of bundle sizes you are producing, then this is good. But otherwise, I would not recommend this. And now I want to show you why this is the case, and also how to shrink your bundles. I like this guy. So as a matter of fact, currently, when we create an external bundle, we get Angular, RxJS, and all the libraries bundled into it. Ivy will help a lot, because Ivy, at least in theory, can down-level everything to code that is quite near to the DOM. That means we will not need much of Angular anymore, especially when it comes to web components. Saying this, the Ivy integration is a post-Angular 8 thing. It is not ready yet. But in the future, this will help a lot. That means we can land back and just wait until this feature is shipped. On this position during the exercise, I want to cite my good colleague, Minko. Minko tweeted a very important thing in December. It is about expectation management, if you ask me. Minko said, yeah, Ivy will enable new features. And it will come step by step. And it may reduce your bundle sizes, but do not expect wonders. Do not expect wonders. It will not make your JavaScript disappear. So let me take a picture of this so I can show to Minko that I presented this. Perhaps he gives me a drink or something. Okay. So what did Minko wanted to say here? Well, Minko wanted to say that Ivy does a big deal when it comes to UI-based widgets. In this case, we can down-level everything to something that is quite close to JavaScript. When it comes to libraries, then it will not make those libraries disappear, so we will stick with the bundle sizes of those libraries. Angular Forms, for instance, or Angular Router, or even Angular Common HTTP. This is library-based, and so Ivy cannot do much. Of course, we can do tree shaking, but tree shaking is also possible nowadays. What you can do is something like this. You can load the libraries once into your browser, and then you can reuse those libraries within your bundles. That means we are doing what we have done back then with jQuery. We load it into our global window object, and then all the bundles will reuse it. For this, we have to tweak the CLI a bit, and to tweak it, you can also use ng-build plus. In this case, the produced bundles will reference the window object. Saying this increases the complexity of your project, and this also leads to a non-default build, so I would just use it when really necessary. But let me show you how this can be used. If you really want to use this, then go to your console, of course. Shorten your prompt. This prevents that you are driving crazy. And then check in everything you have. Very important. So now we have to change our project a bit. That's why I'm checking everything in. Workshop. Okay. I'm creating a new branch. And now I'm saying ng-generate ng-build plus colon externals. Externals, yeah. And now this schematic is changing my project. Okay, I've already done this, so let's do it with --force, which means it's redone. Yeah, as you see here, it changes my project so that this operation mode is implemented. It, for instance, creates a webpack externals.js file. Let's have a look into this webpack externals.js file. It is just a partial webpack configuration file that says, hey, expect Angular core within the window object here, within window.ng.core, and expect Angular common within the window object there, within window.ng.common, and so on and so forth. And this means I just need to load these libraries once, and each and every other self-contained bundle can reuse this stuff. This is how we did it with jQuery. This is how it works sometimes with React. And this is how it works sometimes with Vue. In Angular, you normally don't do this, but here it comes in handy. So let us ng-build this project, ng-build -- project. No, let's use a script, npm run build externals. It is also generated and it contains all those parameters. I don't want to write by hand in front of an audience, you know, the human brain does not work when programming in front of people. And now let's cross fingers and hey, look at this. 9 dot something k, ignore the polyfills, 9 dot something k, that really shows that everything is now compiled into a bundle that does not contain Angular at all. And so this might be already usable nowadays. Saying this, I want to emphasize one more time, this is not an official solution, but even though it can come in handy for specific use cases. Okay, when talking about bundle sizes, we should also talk about zones. Who was in the talk of Maxime this morning? Some of you. He also talked about this topic. Here I'm giving you another view on this topic. So first of all, why do we need zone.js at all? Well, the short answer is zone.js is used by Angular for change detection. And what it does is it patches each and every browser event so that it can notify Angular that an event handler has run, and that means Angular has to do change detection. So it gives Angular every time a hint when change detection needs to be run. Why is this bad for web components? Why this is bad? Because it has more than 100K. And no one wants to use our 3 kilobyte date time picker together with a 100 kilobyte zone.js implementation. Okay, when gzipped and minified, it has 10K, but this is still too much for a 3 kilobyte date time picker. It is somehow awkward to force the consumers into using this. And saying this, there are issues with native async await and zone.js. So don't try to use Angular currently with ECMAScript 2017. The CLI will give you a warning, hopefully, because zone.js cannot batch native async await. It can batch the emulated async await you are getting when using async await and ECMAScript 2015 or 16 as a compilation target. So there will be a future where zone.js will be optional. So the question is, how can we exclude this? And you can do this by just mentioning this noob zone. Noob means no operation, which is just a dummy zone implementation that does nothing. It is the Manfred among the zone implementation that is doing nothing. Funny guy. So what are the consequences? The consequences are you need to do change detection by hand. And that means you can do change detection using observables or just by triggering the change detection directly by hand by using the change detection ref. And saying this, the Angular team is currently discussing possible solutions for this operation mode. Currently, there is not an official solution for this, but the Angular team is thinking about this, and hopefully in the next time we will get an official solution. Let me show you what it means. Let's go into our source code. Let's go into our external dashboard style component. And here you see I am providing everything here as a subject. I'm going with a replace subject. Normally the subject would be part of a store or it would be part of a service. For the sake of simplicity, it's here part of the component itself. This is just for the sake of simplicity. Don't do this at home. Okay. So every time I'm loading new data, I'm just notifying this guy here, this subject, and I'm sending the new data to the subject using next. In the template of this external dashboard tile component, we would now normally use the async pipe. We would pipe data $ to async, but do you know something? Async demands upon zone.js. Async does not work without zone.js. And that's why I've written an own pipe here. It's called the push pipe. The push pipe is an experimental type, and to be honest, I have not written it by myself. I've borrowed it from another project. It is just a prototype. Someone in the Angular team has published this as a proof of concept, as a possible proof of concept, a version of the async pipe that does not need zone.js. And as we have seen before, when we included this external dashboard tile component, it really works. Besides this, we could also do it by hand. We could, you know this perhaps, just get hold of the change detector ref, using dependency injection, and then we could call here this dot change detector ref dot detect changes so that the change detection runs. This is the completely manual strategy. And there are also other ideas. One idea the team lead of Angular has presented at a meetup. It was part of the answer to a question, to be more precise. Precise is something like set properties, something we know from React. If we had something like this, we could say, okay, I'm setting the A property to 1, the B property to 2, the C property to 3, and then guess 3 times what set props is doing. It is setting all those properties, plus it is giving the change detector a kick so that it is performing change detection, dirty checks, and so on. This is also another idea. So nothing is fixed now, but I just want to show you it is a good idea to exclude zone.js. Nowadays you can do everything by hand, and in future there will be some support by the Angular team. Okay, let's go one step further. Let's come to the last topic I want to present you. It is about content projection and the slot API. Who has used content projection so far? Okay, cool. Who has used transclusion in AngularJS? Transclusion is more or less the same. Okay. So, as a matter of fact, Angular itself supports content projection, but this is not the content projection of web components. Web components have their own style of content projection. That means we have to use a different API here. And as this expression within the parentheses tells you, this is part of the Shadow DOM standard. So what I want to do here is I want to write a tabbed pane, a panel that takes some data, for instance, a title or some markup with some formats here. The ipsum here in lorem ipsum is bold, for instance. And as you see, there is also some small printed stuff projected in here. This is what I want to do. And to accomplish this, I have to define placeholders within the template of my component. And those placeholders are done or defined using the slot tag. In traditional Angular, you would go with ng-content. Here we are going with slot. This is one of the changes. You can have as many slots as you want to have. You can have one slot without a name and n slots with a name, for instance, with the name footer. And then when calling your component, you can define which goes into the main slot and which goes into a named slot. Here, everything that is not part of a slot element goes into the main slot. This is this orange lorem ipsum with some tags. And the rest is tagged with slot equals footer, and this, of course, goes into this footer slot. Some extra info with a bold extra. Saying this, to use the slot API, you need Shadow DOM 1, and you need to set view encapsulation to Shadow DOM for this. And that means it will not work with Internet Explorer unless you are loading a polyfill for this. But we are on the safe side here. We have already loaded a polyfill for this very standard. Okay, let's try this out. For this, I'm switching back to my example. I'm switching to a tab component. And this tab component needs some placeholders. I want to have the main placeholder here, slot. And I want to have the footer placeholder there, name footer. Okay, this is the first part of this exercise. Then I'm looking in the module of this tab component. And here you see I have this magic code we have written several times within this exercise. This magic code that exposes our component as a custom element. So we are getting my tabs, we will look into this later, and my tab. Okay, and now let's use this my tab. For this I'm switching to a tabs page component. And here I will call my tab with a title. For the title, I'm using data binding ng-conf 2019, lorem 4 times, and then I'm defining here the content for the footer slot, lorem 1 time. Does that work? Yeah. So let me also use some markup here. Ipsum, and let us do something crazy. Let us call that dashboard tile in there. Dashboard tile. Let's repeat this. Angular Connect. Who is going to Angular Connect in London? Okay, perhaps some of you. Okay. Okay, those are my tabs. Let's have a look into the browser. Where is my browser? Here it is. Go away. Tabs, yeah. And as you see here, I'm getting my tabs. There is some prepared styling, and my markup is projected into those tabs. The markup is placed into those placeholders. I'm even projecting my dashboard tile component here, which is kind of nice, isn't it? But what I really want to have is a tabbed pane that is just displaying one of those items, one of those tabs, either this one, ng-conf, or that one, Angular Connect. And for this, I have prepared another component. It's called the tabs component. And this tabs component also has a slot that displays all its tabs, all its child elements. Let's use this. I'm switching over to my tabs page component. Here I'm using my tabs. This is the name. And because of content projection, all the children are projected one more time. Okay, this is not exactly what I want to have. Okay, I have wrapped everything with the tabs component, but it still shows all the children. What I now need, and this leads us to the slot API, the browser-based API I'm talking here about, is to fetch all the child components, all the tab components, and then to decide which of those tabs shall be displayed and which of those tabs shall not be displayed. For this, I'm going to my tabs component, and here I'm using something that might be new for you, a slot change event. This is part of the Shadow DOM standard for content projection. Slot change shall delegate to slot change, which is a method in my component. It gets the event object. And in here, in slot change, I can use event.target.assigned nodes to get all the projected nodes, all the child nodes here. With traditional Angular, you would just use child nodes. Content children, that's the name. So here I'm getting my tabs and all the other stuff that was projected, and then I'm putting my tabs into this dot tabs. This .depth is just an array with all the depth components. And if you look into my markup here, my markup is iterating all the depths, let depth of depths, and then it is displaying a hyperlink to activate this or that depth. Let's look into this if it works. Here it seems to work. But now we just need to define which of those depths is displayed. For this, I'm calling an activate function, this.activate, everything for the first step. And what is the activate function doing? It is just iterating through all the depths for each depth of depths. It is saying, hey, this depth is hidden. And then I'm displaying my depth hidden equals false. And now I have some way of communicate with my child elements. By default, just the first page is displayed, and if I want to display another page, the other page gets displayed. I think this example is quite nice because it shows several things. It not only shows how to do content projection, it also shows how to communicate with your children. And if you are parents, then you need communicating with children is really, really important nowadays. Okay, cool. We don't have time for this exercise, but you have documented everything, so you can do everything later if you feel happy. Let us come to a conclusion. We have seen that polyfills are important. Without polyfills, this will not work. We've also seen we need this custom element scheme. We've talked about Shadow DOM. This allows us to isolate our styles. We've talked about dynamically adding an element to a page. This is one of the upsides of custom elements. We've talked about dynamic loading and loading external elements. External elements are quite big nowadays, and so we need to use tricks like Ivy. We've talked about zoneless change detection, and we've talked about content projection with slots. So thanks for being here. If you want to follow me on Twitter so we can keep in contact, and you will find all my material on my blog. Have a nice day. Thank you.